G.K.Jain schools, a great way to start your child's early education. Dear students, subscribe our school YouTube channel immediately so that whenever the videos are uploaded, you will get the notifications of the same. Good evening children, this is Padma from G.K.Jain schools. Let us continue with complex numbers from 12th mathematics. In today's class we are going to see exercise 2.8, the very last exercise of this chapter. In the previous classes we had seen what is de Moivre's theorem, applications of de Moivre's theorem, how to find the nth roots of unity, how to find the nth roots of complex numbers, properties also. We have seen the example sums also. So now from this class onwards we will be moving on to the exercise. The exercise is having lot of problems, like all the sums are important and frequently asked in 5 marks. So we will be seeing this exercise for the next 2 classes. Let's move on to the topic now. Now let us go through the basics once again. First let us see de Moivre's theorem. You all remember cos theta plus I sin theta the whole power n can be written as cos n theta plus I sin n theta. That is, the power will be brought to the argument, and all these things we saw in the yesterday's class. The sum of nth roots of unity 1 plus omega square is equal to 0, and the product also it is minus 1 the whole power n minus 1. And this is the exercise what we are going to see in today's class. First we will see the first 3 sums. Let's move on to the sums now. Exercise 2.8. The first sum, if omega not equal to 1 is a cube root of unity, then show that a plus b omega plus c omega square divided by b plus c omega plus a omega square plus a plus b omega plus c omega square divided by c plus a omega plus b omega square is equal to minus 1. So this is the question. We are asked to prove that LHS is equal to RHS, which is minus 1. So now let us see what are all the things we can use in this. First they have given that omega is not equal to 1 and it is a cube root of unity, which means we can make use of the properties. Okay, so first let us consider the LHS. Before that, since omega is not equal to 1 is a cube root of unity, we know that these properties exist for the same. That is, these properties are applicable for this sum. There is 1 plus omega square is equal to 0, which we went through in the basics also now. Once again, that's why I went through it. And now omega cube is always 1. So using these facts only, using this concepts only, we will be working out this sum. Let us consider the LHS now. A plus b omega plus c omega square divided by b plus c omega plus a omega square plus a plus b omega plus c omega square divided by c plus a omega plus b omega square. Listen carefully children. Now what I am going to do, wherever a, like here in the numerator, here it is a, okay. If a is there, I can write it as a into 1, right? I can write it as a into 1. So wherever 1 is there, I am going to replace it as omega cube. Is that clear to you all? Wherever 1 is there, I am going to replace it as omega cube. So here what will happen, a omega cube plus b omega plus c omega square plus, here also I can write it as a into 1, and here this b omega I am going to write it as b omega into omega cube, because omega cube is 1, omega cube into omega is omega power 4. And what is omega power 4 children? Omega power 4 is equal to omega cube into omega. Omega cube is 1 into omega is omega. So I can write this b omega as b omega power 4. Why we are writing like that? That you will know in the next step. Okay. Plus c omega square. Now what happens? I am going to take omega from the first numerator. So what happens? I am taking omega outside. So this becomes a omega square plus b plus c omega. Plus here what I am doing? I am taking the omega square outside. So this becomes a omega plus b omega square plus c. Now see children, see the numerator and denominator, b plus c omega plus a omega square, b plus c omega plus a omega square. So this and this will get cancelled. Similarly here, c plus a omega plus b omega square, here also c plus a omega plus b omega square. This and this will get cancelled. So finally it is omega plus omega square. And listen, see this children, 1 plus omega square is equal to 0. Means omega plus omega square can be written as minus 1. So this can be, this omega plus omega square becomes minus 1. So it is hence proved. That is what we are asked to prove, right? Can you all see here? a plus b omega plus c omega square divided by b plus c omega plus a omega square plus a plus b omega plus c omega square divided by c plus a omega plus b omega square is equal to minus 1. Hence proved. So you all understand. So these two are the important properties using which we have proved it. Okay. Now we will move on to the second sum. The second sum is very, very important, children. This is 5 mark sum. Show that root 3 by 2 plus I by by 2 the whole power 5 plus root 3 by 2 minus I by 2 the whole power 5 is equal to minus root 3. The biggest advantage in complex number 5 marks is it will have a plus minus difference only. Can you all see this expression and this expression are same, only the difference is symbols. So when you are working out for this expression which is having a plus symbol, after getting the answer by interchanging the minus, you can get the expression for the minus also. I mean for this expression also, for this one also. So what we are going to do, first we will consider the first expression, root 3 by 2 plus I by 2 is equal to r into, as usual whenever we are given the complex number, we will convert it into the polar form. R is equal to r into cos theta plus I sin theta. So r is equal to root of x square plus y square. This is my x plus iy. So my x is root 3 by 2, my y is 1 by 2. So I am substituting root 3 by 2 the whole square plus 1 by 2 the whole square. That is 3 by 4 plus 1 by 4, which is equal to root of 4 by 4. 4 gets cancelled, root 1 is 1. Now I will go for the theta part. So tan alpha is equal to y by x. What is my coefficient of y? It is 1 by 2. Coefficient of x is root 3 by 2. So when I am doing this, root 2 and 2 gets cancelled, it is 1 by 3. So alpha is equal to tan inverse of 1 by root 3. So 1 by root 3 means it is pi by 6. What is pi by 6, children? It is 180 by 6, that is 30 degree. That is what we are converting here. Now where this both are plus, so theta lies in the first quadrant. So theta is equal to alpha, therefore theta is equal to pi by 6. Now write the conversion. Root 3 by 2 plus I by 2 is equal to, r value is 1. Can you all see? R value is 1. So 1 into cos theta is pi by 6. So cos pi by 6 plus I sin pi by 6. So root 3 by 2 plus I by 2 is equal to cos pi by 6 plus I sin pi by 6. Now our root 3 by 2 plus I by 2 the whole power 5 becomes cos pi by 6 plus I sin pi by 6 the whole power 5. Now you all remember the De Moivre's theorem? We went through it now also. That is cos theta plus I sin theta the whole power n can be written as cos n theta plus I sin n theta. So bring this 5 here, no? So this becomes cos 5 pi by 6 plus I sin 5 pi by 6. Now this is for the plus. Now what will happen for the minus? The sign will be changed here. So we are having root 3 by 2 minus I by 2 the whole power 5 is equal to cos 5 pi by 6 minus I sin 5 pi by 6. If you are going to work out it separately, the modulus and theta value also, you will get the same only. That's why just by interchanging the minus sign, we are getting the answer directly. Now write the expression together, no? Root 3 by 2 plus I by 2 the whole power 5 plus root 3 by 2 minus I by 2 the whole power 5 is equal to cos 5 by 6. So cos 5 pi by 6 plus I sin 5 pi by 6 plus cos 5 pi by 6, in between we are having a minus sign. So this minus I sin and plus I sin will get cancelled. So we will have cos 5 pi by 6 plus cos 5 pi by 6. That is 2 cos 5 pi by 6. Now shall I write this 5 pi by 6 as 6 pi minus pi? What is 6 pi minus pi? It is 5 pi. Now if I am going to split this, no, like 6 pi by 6 minus pi by 6, 6 and 6 get cancelled. So I can write it as pi minus pi by 6. Directly also we can write. Just for your understanding purpose, I have shown that step. So it is cos pi minus pi by 6. And what is cos of pi minus theta, children? What is pi? 180 degree. We know that cos of 180 minus theta is minus cos theta. So this becomes minus, what is theta here? Pi by 6. And what is pi by 6, children? It is 180 by 6, that is 30 degree. So cos 30 is root 3 by 2. 2 and 2 gets cancelled. So it is minus root 3. So root 3 by 2 plus I by 2 the whole power 5 plus root 3 by 2 minus I by 2 the whole power 5 is equal to minus root 3, hence proved. That is what we were asked to prove. So it is proved. Okay. So this is also important 5 mark sum. Now we will see the third sum, children. Find the value of 1 plus sin pi by 10 plus I cos pi by 10 divided by 1 plus sin pi by 10 minus I cos pi by 10 the whole power 10. Usually we will have cos theta plus I sin theta, and this sum it is little different. Okay, this is we have seen a similar sum in the example also. So first what we will do, we will assume the sin pi by 10 plus I cos pi by 10 as z. So if sin pi by 10 plus I cos pi by 10 is z, what about sin pi by 10 minus I cos pi by 10? Obviously it will be 1 by z. So substitute 1 plus z by 1 plus 1 by z. Take LCM, it is z plus 1 by z. So this denominator, when it goes to the numerator, 1 plus z gets cancelled. So you will have only z. So this whole expression was simplified to z. So the power 10 means z power 10. So now I am having sin pi by 10 plus I cos pi by 10 the whole power 10. Now listen very carefully. I am going to take I power 10 outside. When I am taking this I power 10 outside, when I am going to bring it here also, I will get back the expression as usual. See here why I am getting a minus sign here, because I power 10 into I is I power 11. See, I power 10 into I is I power 1, that is I power 11. If it is I power 11, I can write it as I power 4 into 2. That is, you remember the very first exercise, how to convert the I expression. You have to write them in multiple of 2 plus remainder. So 4 2s are 8 plus remainder is I cube. So I cube means I can write it as I square into I. I square is minus 1. So that is minus here, and the left out I is here. And I power 10, when it is coming inside, it will become I into cos pi by 10. Okay. So that is why we are deriving this expression like this. And after this, since we have brought it to the usual format, now I can write this I power 10 as I power 8 into I square. Again, I power 8 is 1, but I square is minus 1 into cos. Now using De Moivre's theorem, cos theta plus I sin theta whole power n is cos n theta plus I sin n theta. Bring this 10 here, 10 and 10 gets cancelled, 10 and 10 gets cancelled. So here I am having minus 1 into cos pi minus I sin pi, and cos pi is minus 1, sin pi is 0, so minus into minus become plus 1. So 1 plus sin pi by 10 plus I cos pi by 10 divided by 1 plus sin pi by 10 minus I cos pi by 10, the whole power 10 is 1. So this is how we have to do. This is also very important 3-mark sums, and we will be seeing the rest of the sums in the next class, children. As of now, third sum is over. We will go ahead with the rest of the sums in the upcoming classes, children. Thank you all.